Whoa. Okay, so welcome guys. So in the previous video, previous two videos that we already used mathematical induction to solve 5 of these. So now I start to build a YouTube channel. I start to build a PowerPoint. Basically, there's an interesting. I collect a lot of mathematical induction, and let's go through one by one. And it will start from the easiest to the difficult. And this video is just the easy version. Next video will be some problem which is much difficult than the trivial one. Okay, so let's go to see some trivial one. It says that prove n factorial greater than 3n for n greater or equal to 7. So when I start, before I start, please subscribe to my channel. Okay, so let's first check n equals to 7. So it's very easy. I already compute 7 factorial is 5040, and 3 to the power 7 is 2187. So yeah, the n equals to 7 is okay, right? And suppose n equals to k is correct, so that means k factorial greater than 3k. How about k plus 1 factorial? K plus 1 factorial will be k plus 1 times k factorial greater or equal to k plus 1 3 to the k, right? By our assumption. Now k is greater or equal to 7, right? So I can let it greater or equal to 8 times 3 to the k. So it will greater or equal to 3 times 3 to the k. So it's 3 to the k plus 1. Okay, so k plus 1 factorial greater to equal to 3 to the power k plus 1. So the proof is done. Okay, so this is the easy exercise. Let's say another exercise says that xn plus 1 equals to square root of 1 plus 2xn. This is a rule. And I tell you that x1 is 1. And I hope you prove that xn less or equal to 4. Okay, so the first one is that when n equals to 1 is obviously correct, right? Because, I write down some, this is nonsense. This is 1 plus 2. So it's a square root of 3. So it's 1.327. So yeah, ground truth is okay. You need to modify this line, okay? N equals to k is correct. Let's assume that sk is less or equal to 4. How about n equals to k plus 1? So sk plus 1 equal to 1 plus 2xk less or equal to square root 1 plus 2 times 4, right? Because I use this, which is 3, right? So we first prove that sk plus 1 less or equal to 3. So it's definitely less than 4, right? So our induction step works. Okay, and some serious example I want to talk is that this is a famous one. So I think once you understand this, everything is trivial. So 1 plus 3 plus 5 plus up to 2 and minus 1 will give you n squared. Let's say n equals to 1, right? So 1 equals to 1 squared. N equals to k, 1 plus 3 plus 5 plus 2k minus 1 will be k squared. How about n equals to k plus 1? So n equals to k plus 1, you will add a term called 2k plus 1, right? So your right hand side also add a term 2k plus 1. And it's easy to show that by your elementary school mathematics tell you that this is k plus 1 squared, right? So induction step works. Okay, so finally we have also two final example. 2 to n greater than n factorial for n greater or equal to 5. If n is 5, then 2 to the 5 greater than 5 squared, right? This is 32, 25. If n is k, then suppose that n equals to k is correct. So means 2 to the power k greater k squared. Okay. Now n equals to k plus 1 is 2 to the k plus 1 equals to 2 times 2 to the k, which greater or equal to 2k squared. Okay. So now idea is that we hope to show that 2k squared greater or equal to k plus 1 squared. And if you expand it, then it's obviously then when k greater or equal to 5, then obviously this success, right? So always 2 to the k plus 1 greater or equal to k plus 1 squared. Okay, final theorem, which is also trivial, says that for n greater or equal to 2, n squared greater than n plus 1. So n equals to 2, 4 greater than 3. N equals to k, k squared greater than k plus 1. So n equals to k plus 1. So let's talk about n equals to k plus 1. K plus 1 squared minus k plus 2, right? Because I want to. So we want to show that k plus 1 squared greater than k plus 3. K plus 2. So we just use their difference and hope their difference is greater than 0. Okay, so k plus 1 squared minus k plus 2, k squared plus 2k plus 1 minus k minus 2. So it's k squared plus k minus 1, right? By induction, k squared greater than k plus 1. So this is 2k greater than 0. Okay, so we prove. That's it. I will see you guys in the next videos.